Okay, good evening. Welcome to
FamilyMath number 879.
FamilyMath879. So this is a website and a program by Albert and Carl Friedrich that I found thanks to Steven Strogatz. And we're going to play around with it this weekend. But what it's going to talk about is something called random walks. Do you know what random walks are?
So you start at the origin on like a plane, and then you pick one of the 4 directions to go, and you go that direction.
Okay. What do you think?
Mm-hmm. Well, you start at a point, and then you pick a random direction to go, and then you go in that direction. Then you're at the next point, and then you repeat that process. And you kind of see where you go. All
right. And so in this program, let's see if I can zoom in just a little bit. It's always dangerous, so I forget I'm zoomed in. In this one, the random point is sort of picked anywhere in a distribution, in any direction around there, in something called the Gaussian distribution. Do you know what that is?
Oh, no.
No, do you?
Is it kind of like the normal distribution where you have the probabilities are higher near the center?
That's right, but it's just a 2-dimensional version of that. So your high probability are sort of nearby, low probability to go far away in a direction.
Yep.
This next one can go in. It's always going to pick a point along the circle, so it's always going to go a distance of 1 unit, basically.
All right.
But in a random direction. Here, this one, it's going to pick one of the 4 directions and take a step in that direction.
Yep.
And this one is interesting. It's going to go one of 3 directions. You see those 3 dots?
Mm-hmm.
Yep.
Now, which one would you like to see first?
How about the triangular one?
Okay. Mm-hmm. So I'm going to turn these other ones off. And my first question to you is, what do you think this triangular random walk is going to look like?
Well, since you might have like sometimes where you go like start at this point, then you go out this way, and then come back, you might see some triangles.
Okay.
There can be overlaps, right?
Yep.
Yep. So it's going to be sort of like a triangular tiling almost.
All right, what do you think?
Well, you're going to have a lot of 60-degree angles. That's kind of really all you can say, since it's triangular.
Okay. Let's see. Tell me, sort of describe what you're seeing here.
So I'm seeing a lot of those triangles, but also there are some empty spaces. And then sort of coming back to where I was. It's not really staying in the same space.
So it kind of looks like it goes out. Like what it does is it goes out and then kind of bounces around at its new area, and then eventually that rejoins the main structure.
Okay, why do you think that happens?
Well, it's I guess just random chance. You kind of just get a couple, like, if you get a couple like of this in a row, you just go out a little bit. There, you did it again.
All right. So, what is this? Is this what you thought it would look like, or is it different? Or so tell me what you make of this.
Well, from when it just started, it sort of looked like what I thought it would, but when we got sort of farther out, it kind of got mixed around a little bit. You can still see there's like a 60-degree angle right here.
Okay.
It's still moving in that.
It's definitely very angular. I think it stopped.
It stopped.
Oh, it stopped. Mm-hmm. We reached the end. Okay. So now we have a shape here that sort of traces out the path.
Yep.
Okay. So we're going to try to see when we do a different one. What's different about the next one? Okay.